I'm going to talk you through question number 4 again from chapter 22, part 2 assignment. On this one, really what's being assessed for you here is your understanding of the p-value. And through a couple of examples that I provided in class before we were pushed off campus, I know we talked about p-value, but it does get lost in the shuffle. So just as a reminder for you, the p-value is the probability that you obtained what you did in your sample, or that you get something more extreme than that, assuming that the null hypothesis is true. So really, some keys here for p-value. P-value is a probability. So it's the probability of obtaining the results or something more extreme so the results that you did in your sample again, with the key part being here that you are assuming the null is true. So you don't actually know that the null is true, but that's what you're saying with the p-value is if the null was true, what is the probability that I went out and I got my sample and this is what I got? So as we look at this one here, this one is the one that's talking about the amount of money spent on a date. So a magazine article reported that college students spend an average of $100 on a first date. A university sociologist believed that the number was too high for the students at the university. The sociologist surveyed 32 randomly selected students from the university and obtained a sample mean of $92.23. So there's what she obtained. A one sample t-test resulted in a p-value of 0.026. Which of the following is a correct interpretation of the p-value? Okay, so on this one, what we would be assuming is true is the $100. So that's your claim. So that would be your null, essentially. So if we read through these options, A says the probability is 0.026 that the mean amount of money students from the university spend on a first date is less than $100. So that's not what we're saying with a p-value. We're never just saying that it's a directional. It's the probability that you got what you did in your sample. So that means that we could take out A. On B, the probability is 0.026 that the mean amount of money students from the university spend on a first date is less than $92.23. So again, not what we're trying to find. And then C is going to be able to be knocked out for the same reason because it says that the mean amount of money is more than $92.23. So that really leaves us with D and E, which are going to look similar in setup. So on D, it says, if the mean amount of money that students from the university spend on a first date is $100, so there's that statement of like assuming that the null is true, the probability is 0.026 that a randomly selected group of 32 students from the university would spend a mean of $92.23 or less on their most recent first dates. Moving down to E, because it looks very similar, so we're going to have to find the differences in these. If the mean amount of money that students from the university spend on a first date is less than $100, the probability is 0.026 that a randomly selected group of 32 students from the university would spend a mean of $92.23 or less on their most recent first dates. So one of the key differences here is going to be in the first part of the statement. So on part D, if the mean amount of money that students from the university spend on a first date is $100, then when we jump down to E, it says if the mean amount of money that students from the university spend on a first date is less than $100. So hopefully from this definition that I gave you of p-value, you can see that your correct answer here would be D, because we have to have that null hypothesis that we're working against. The null is, or the claim is, that that amount spent is $100. Now, the other question that I answered in a couple of Canvas messages was about this idea of or less. So that or less is corresponding to this statement that I made up here of something more extreme. So if something was more extreme in this case, it would be moving further away from the $100 claim. And since 92.23 is already less than, that means it would be moving closer to zero, right? Further away from 100. So less or more extreme would mean less than in this case as well. I hope that helps with this one. If it doesn't, Canvas message me and we can talk through what you were thinking.